Explanatory power. The explanatory power of the quantum mechanical model. So the chemical properties of elements are largely determined by the number of valence electrons. I kind of covered this already. The element properties vary in the periodic fashion because the number of valence electrons varies periodically as well. And so the quantum mechanical model explains why hydrogen is reactive and why helium is inert. And it explains a lot of other things as well. It turns out that if your valence shell is full, you're happy and you don't react very much. Very stable. So helium's valence shell is full. There's 2 electrons that can fit in that first shell. That's what we've got, and it's happy and it's stable. Hydrogen only has 1 electron. It's not full, and so it's going to be more reactive. It's going to react in a way to fill up that shell. So atoms with 8 valence electrons, or 2 for hydrogen, are going to be really stable. All of these have their valence shell full. These guys have the second, neon's got the second level, argon the third, etc. But they all have 8 valence electrons, except for hydrogen who has 2. But he's happy with 2. And so they're not going to react very much because they have 8, and that's the most stable configuration. Alkali metals, group 1, are very reactive. And the reason that they are so reactive is they all have 1 valence electron. What sort of an ion does lithium form? What's the charge on a lithium ion? +1, right? How do you become a +1 ion? You lose 1 electron. Well, when lithium loses an electron, its electron configuration becomes the same as helium. Helium's really stable. These guys react so much because if they just ditch 1 electron, they get to that full valence shell and become much more stable. And so they're going to react in a way to do that. We need more explanation of that. So let's look at sodium. The electron configuration for sodium is neon and 3s1, right? So for the sodium ion, it becomes a +1 ion by losing an electron. So we lose that guy. Now its electron configuration is the same as neon. It does not become neon. Okay? It still has 11 protons. Neon has 10 protons. Okay? We're just changing the number of electrons. But it becomes like neon in terms of its electrons. And so that's a much more stable situation, and that's why sodium forms a +1 ion. I think of electrons in many different ways. Sometimes they're like Andrew, but they can also be like our clothing. Okay? The number of protons in the nucleus is your identity, it's your spirit, it's your soul. Okay? Who you are, you can't change who you are. You can change what you look like, though. You can do crazy things to your hair, you can dress however you want, you can look like someone else, but you can't become someone else. And so sodium wants to look like neon. The halogens are like those cool kids in high school that everybody dressed like because they were hoping, well, if I look like them, maybe people will think I'm cool too. It doesn't work though, does it? But everybody's trying to be like them. And so sodium says, hey, if I get rid of 1 electron, then on the outside, my electrons are going to look just like neon. So he'll ditch an electron, and then he'll become like neon. He's still sodium, though, because his core didn't change. His nucleus didn't change. The second group, group 2A, all of these guys have 2 valence electrons. They have 2 more electrons than the previous noble gas. What kind of an ion do these guys form? They form +2 ions. When they lose their 2 valence electrons, they then have the same electron configuration as a noble gas. And so then they're stable. Let's look at the halogens, group 7A. All of these guys have 7 valence electrons. So fluorine has 7 valence electrons, 2s2, 2p5. The noble gas right next door is neon. Neon has 2s2, 2p6. Just 1 electron short of that ideal. So what do the halogens do? They're going to react in a way that they gain an electron. Because if you add 1 electron on here, all of a sudden fluorine has the same electron configuration as the noble gas. It's an ion. It's fluoride ion with a -1 charge. All of these guys form -1 ions because they want to gain 1 electron. The reason they gain 1 electron is because then they have a noble gas electron configuration, which is lower in energy, it's more stable. So this explains what we learned when we talked about nomenclature of these patterns. These guys form +1 ions so that they can have a noble gas configuration. These guys form +2. These guys form -1 because if they gain 1 electron, they'll have the same number of electrons as a noble gas. The next group over will gain 2 electrons. The next group over, like nitrogen, if he gains 3 electrons, he has the same electron configuration as neon. And aluminum, gallium, and indium, they have 3 valence electrons. It's easier for them to lose 3 than to gain 5. So they're going to go the shortest direction to 8 valence electrons. Is that cool or what? Kind of? Give me a kind of cool? Any questions?